Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is component testing, and we will be focusing on the fuel injector. And I think this may, over time, if we get enough good feedback about this, I suppose, it could be a running series and go through different components every week on how we would test different components. So today, we're going to start with the fuel injector. And how can we test components, especially this fuel injector as it sits? Well, we can test it electrically, right? By verifying the circuit integrity, we're going to check the voltage going through, verify the component is operating, or at least the circuit is operating properly, and that's our electrically, so using a voltage probe. And then we can also check it mechanically by viewing the current flowing through the circuit, controlling the component itself. And that helps us verify the mechanical motion, because we can see, based on how that current is flowing through that current ramp, whether or not that injector is actually opening, and whether or not we have a bad spring. We can tell that too. And then we can also check this fuel injector, since it flows fuel, we can check it hydraulically, view the pressure change and the drop across multiple injectors or across the one injector if we're just checking one. Helps us verify the state of flow, because it could still be opening, and for some reason, maybe it's clogged on the way in, or maybe it's not flowing any fuel. So we wouldn't really see a pressure drop when it opens. So there's 3 different ways to test it. And we're going to walk through a couple different scenarios and how we would do that. And we can actually get them all together on the same screen, kind of something like this. So if we were to take a look at a fuel injector, we can see normally on a normal fuel injector, should I say a standard gasoline fuel injector. It's a cross section of that. We have this pintle down here, and that sits on a seat, and that's what closes off the fuel. So it allows it to not spray fuel. And there's fuel all around. And then we also have some other seals in here. There is a spring, and this is a return spring that pushes that back closed when it's done being opened. We also have a coil of wire that goes around. That's represented by these beige-ish boxes over here. So that'll be a winding of coil electromagnet, pulls that pintle up off the seat, and that's what allows it to spray fuel. So on a standard gasoline fuel injector, or at least many styles of standard gasoline fuel injector, you'll have power come in. So usually it's just a battery supply off a fuse or through a relay, or both, right? Comes from the fuse through the relay, I suppose. But you'll have a power supply. And then it'll be grounded control side by the PCM. The PCM will have a injector driver in there most times. That'll pull it down to ground, and that will be what completes the circuit, charges the coil, and then the pintle is able to leave the seat. So once we do ground that, that's where we would see on the signal where it pulls down to ground. So we have the voltage comes in, then it pulls down to ground when it sets that coil to start. And then as it does that, it rises up and it starts spraying the fuel. When that ground is then released, all of that collected energy that was inside the coil has to go somewhere. It works on a very similar principle to an ignition coil, where it stores that energy. So when that energy is stored, it has to go somewhere. So that's why we get that spike at the end there. So we'll have all that collected energy over the time that it was grounded, and then we get that spike at the end. And then over time it dissipates. And this little bump right here, this oscillation they call it, it's actually the point where that pintle snaps shut and stops spraying fuel. So it releases it and then it has to go back down. So you do get that little extra bump when it makes contact and closes. So we can see it where the PCM is commanding it on and where it actually closes right there. So that's voltage checking it electrically. Now, if we want to check it mechanically, we would use a low amp probe, put it around one side of the circuit, either on the power side or the ground side. And once again, it's going to come in. We should have 0 amps when there's no voltage flowing through the circuit. We'll have 13 or so volts right off the alternator. But as far as amperage is concerned, we should have 0 amps. Then when the PCM grounds it, amperage starts flowing through the circuit. So we see it ramp up, and then we see this little dip right there. That dip is the point where that pintle leaves the seat, starts spraying fuel, because that amperage will build in through that coil as the coil is charging. Once the coil is charged, then the pintle starts moving. So all of that takes a little bit of time. We're only talking about maybe a little over a millisecond and a half between when it starts charging and when it actually opens. But this little bump tells us that that pintle is open. So it charges it up and then the pintle opens. It gives us a little less resistance in the circuit. So we get a little less amperage needs to go into the circuit. So that's to overcome that mechanical force on the spring. You want to keep an eye on that. If it opens the same time every time on the same injector, if we're looking at a single injector at a time, you want to keep an eye on that. Make sure it does open at the same time every time or relatively close. If it's going up here, down there, and kind of going up and down all around, opening erratically, more than likely you have a broken spring in there, return spring, and it's just kind of wobbling around in there, not really opening the way it should. Then when the ground is released and it's time to close, well, the amperage goes away when the voltage goes away. All right, so we don't have any more voltage flowing through the circuit, so we don't have any more amperage flowing through the circuit. Then if we wanted to check pressure at the same time, remember all of these things happen at the same time. We're just seeing 3 different ways to examine it. So pressure comes in. When we ground it, the pressure will drop. Now, this doesn't have a drastic pressure drop on this particular vehicle. This is a returnless system, so I think it's just a less of a drop there. So once it does charge and it opens, it's spraying fuel. So fuel is spraying through the fuel injector. So you will see at least a few PSI worth of drop in there. So we see it goes from about 35 PSI down to maybe 31 PSI, 32 PSI, somewhere in that range. So we see it comes in and goes down. And then when it releases, in this case, when it closed, we have a little bit of a backup now, right? Because it was flowing fuel. Then all of a sudden that door closes. The exit door, which would be the nozzle, closes. So we have that little backup. So there's a little little jump in pressure, goes up to maybe pretty close to 40 PSI on there. So once again, not a ton of difference on this vehicle from low to high, but you can see where it does drop off, and you can see where we do have that little extra bump backwards in the system, a little extra pressure coming in through the system there. All right, so that is our 3 separate pressure, voltage, and amperage. And if we were to put it all together, it looks like this. Voltage comes in, and as soon as it grounds it, amperage rises, pressure falls. Notice how the pressure bump coincides with the spike on the voltage and the drop off in the amperage. So everything lines up. And that's why we use a scope with multiple channels to be able to compare all 3, 4 different things, depending on what we're looking at, compare multiple items at the same time on the screen in the same time base with each other, right? So that's how we have that grounding event right there. The amperage coincides and the pressure coincides. So everything kind of goes together in there. So let's see how we might apply this in a real world case study that we have. So this is on an 02 Ford Explorer, and it was a no start after the PCM installed. So our buddy Scott Manna out in Des Plaines, Illinois, helped us out with this one a little while ago. And the scenario was the PCM was replaced at another shop. I believe it was a transmission shop. The engine was able to start after they reset parameters and such, but a short time later, it wouldn't start anymore. So where's the first place we want to check on anything with a vehicle with a problem like this or a no start problem? Well, we want to start with checking for codes. Now, this is an 02 Explorer, so that is back a little ways, right? That's a 19-year-old vehicle, but no code scan. We can't scan the full vehicle because it doesn't go back that far. But we do have where we can just go in and check for codes in our engine. So we'll go into engine, and we'll go in here, and a few different ways we can go through here, and we'll go to codes menu. So go to codes menu, and then Ford, as you may know, if you've gone through and scanned Fords before, we have a key on engine off self-test, key on engine running self-test, memory codes, and pending codes. So in this case, we want to do a key on engine off self-test. So we'll go in there, and we see a wealth of codes, many codes on this vehicle. So intake air temperature circuit high, engine coolant temperature circuit high. Everything seems to be a high input in this case, and multiple sensors. Scroll down a little more, we get even more, right? So there's a couple pages worth of codes on this vehicle. So I said, all right, well, it doesn't really give us a starting point since it seems to be multiple sensors on this vehicle with a 5-volt signal problem. Check for spark. That was okay. It was sparking. We had spark. Maybe we don't have fuel. So was the wrong PCM installed? That's a possibility as well. It could be maybe some sort of a PATS issue or something. And then check for fuel pressure with the gauge. We want to make sure fuel is getting to the injectors, right? Because we got spark, we got fuel. Then it leaves us to a mechanical problem, right? Compression. We need fuel, air, spark, compression, right? So it could be air or compression if we have fuel. But let's see if we have fuel first. We'll check for fuel pressure with a gauge. Hook up the fuel gauge, and it does the most curious thing. Wildly fluctuating from about 30 to 60 PSI. It's going crazy, right? It's going up and down like that. It seems like every time an injector would fire, right? So that's a little curious. So let's get a scope on it. Let's see what we can do in order to solve this problem. So we'll go into well, first off, we'll go in the shop key, right? And we'll see what is the pressure spec supposed to be on this vehicle to begin with. So we'll go into shop key, and we'll just look under our common specs and procedures here, which is going to be on the quick link button there. So we'll go in there, and we go down to, we got fuel pressure spec. It is a 4-liter. We'll click on the link, and then it's an Explorer. So we'll look at Explorer. It should be 60 to 65 key on engine running. Then key on engine off as well. It should be 60 to 65 PSI either way. So we'll hook up the pressure transducer. Let's see if we can get eyeballs on this and see what we have going on. So we hook up the little pressure transducer there to the fuel line. And here it is building pressure. So we have very little pressure there at the beginning. Key on engine off. Let that fuel pump build the pressure. We get it to about a little over about 61 PSI, something like that over there at the top. Looks like we have, and this is a reading. Yeah, so it gets out to about 60 PSI at the top. And then we get to cranking here, and we see drops from, let's see, well, it started about over 60 PSI. As soon as it started cranking, dropped down to 20. And then it built back up to a little over 40, and then it dropped down and built up to about 40 and dropped down a little below 40, and so on. We see it settling into that 35 to 40 PSI range every time it cranks. So there's a massive drop in that fuel pressure on this vehicle. So that's confirming what we saw on the gauge, right? So wide fluctuations during cranking. So that was on scope channel 1 for the pressure. So we'll take channel 2 and connect for the injector control signal. And number 3, we'll connect with a current probe to look at this from hydraulically as well as electrically and mechanically. So hook up there. There's a hookup for channel 2 and so on and so forth. And then there's amp clamp there. And here is just an example of what we would see if we're in nice and close here on the 500 milliseconds time base. We have our voltage is the green line, the yellow line is the pressure, and then the blue line is the amperage. So you see it goes from about 60 PSI down to about 40 PSI there at the same time that injector is commanded on. So they're all tied together. Pull out a little bit further, see what we got for going on here. So it goes from 60 to 40, 30, back up, makes it up to 60, back to 30 in this case. So we can see every time there's a huge pressure drop. Now, why is there such a pressure drop? You may, if you have a keen eye, you may be able to see where the issue might be, but we'll pull up our measurements here and see what we got going on. So for this is one firing event on this fuel injector. And that fuel injector is firing 250.58 milliseconds of on time. That is like an eternity, forever. It's a quarter of a second spraying fuel. That's why it's dumping all of that fuel pressure. Right? It's dropping all that fuel pressure because it's open for a ridiculously long amount of time, way too high, causing this fuel pressure drop. And might I add, you know, it's 60, 70 degrees outside ambient temperature. So it definitely shouldn't be on for that long. Injector on time's too high, causing that fuel pressure drop. And with so many sensor codes, they're all tied together on maybe a 5-volt reference circuit. So let's test that 5-volt reference circuit. Now, the easiest place to test it on this vehicle is a DPFE sensor, which stands for Delta Pressure Feedback EGR sensor. And it's like right on the firewall, real easy to get to. You can just back probe it right there and see what's going on. So here's a little video they took of actually doing this test. They got a meter on there. It's about 0.5 volt on the 5-volt side. Unplug it, goes up to 5 volts. Plug it back in, goes back down to 0.5 volt. So it's from 0.5 volt to 5 volts. So we are dropping 4.5 volts or so off of that circuit just by plugging it in. So the 5-volt reference circuit, so that is pulling it down to ground. That is a short to ground. So that DPFE sensor shorted that 5-volt reference circuit. So they replaced the DPFE sensor. Luckily, it's the first thing they checked on, right? And that happens to me all the time too, where I'm trying to test something and then we just test on the thing that we think is bad and it tests bad. And well, of course it's tested bad. We thought it was bad. But it's always good to test other things as well. But by unplugging it, that takes it out of the equation so that we can understand that, yes, it was shorting out that 5-volt circuit, pulling it down, and we were losing 4.5 volts on that 5-volt reference circuit. So here we go. Check it again after it's replaced. Crank, 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 start it up. And we see it goes from 60 down to about 50 PSI when it fires. But our firing time is way down to 36 milliseconds at startup. So that's a lot more reasonable amount of time than 250 milliseconds on startup. And then, of course, after it's gone through, go through and check for codes again. No codes present. Now, let's back up a little bit. Why, if the 5-volt reference circuit is short, why would it have such a large on time and how would that affect it? Well, if we think the coolant temperature sensor, for one, if it is set that way in order to have, if it has a low voltage, that means cold weather. Maybe it's defaulted down to that negative 40 degrees that a lot of them seem to fail at. So it pulls it down to a lower temperature. So the ECM doesn't know any better. It just thinks, well, it's a low temperature outside. So then it just says, well, we got to fire that injector a lot longer in order to start that thing in a low temperature, right? So we suspect that's what the issue was. And the computer just got a little confused there and decided, well, let's just spray the heck out of it. You probably want to change the oil on that vehicle too after it's done with dumping so much fuel into that cylinder and not firing, right? It's probably washed down the cylinder. So definitely want to change the oil on that thing too, I think, after the fact. So there's a cool little case study for you, bringing it all together where we can do voltage, amperage, and pressure at the same time. So now let's walk through a couple little functions on the tool here that relate to what we were just talking about here. So on our tools with the guided component test function, so that would be on the Zeus, on the Varus, on the Modus, on the Tritons. We have a guided component test function in there on the tools with the scope. And one, I don't know if it's really a hidden feature, but it's one we don't talk about a whole lot. And I think we should talk about it a lot more than we do. There's built-in training and classes on this scope training. So we can go into training and classes. It's in all the tools, at least the ones that have got a component test anyways. And we talk a lot about how-to because there's a ton of information in how-to, but let's go to power user test because there's a few things in there we can do as well. So we have pressure transducer test, secondary ignition, current probe tests go in there. So we have got to choose a current probe first. We can use a generic probe, the old style red low amp probe from Snap-on, or the new style black color one. And then we do current ramp testing. So first one right there is fuel injector, right? We can go through things like even ignition coils and parasitic draw, but in this case, we've been talking about fuel injector all night, so we'll use fuel injectors. And then it asks us for the injector type because there are multiple types of injectors, as I've said earlier. So we have our conventional, our peak and hold, are pulse width modulated with current control and pulse width modulated with volume control. So let's just walk through the few different styles here as to what we would do. So we'll go into conventional. Tells us how to hook up, connect, where to set the amp probe up, where to hook up to the wire, where to plug it into the meter. And then it gives us our example patterns down here at the bottom. All right, so should have a gradual rise in the ramp. If it goes up sharply, that also indicates some issues with the windings in there. So we want it to come up in a nice smooth ramp. I forgot to mention that earlier. So if we're looking at a coil ramp, we want to have it go up in a nice smooth ramp. If it goes up sharply and then over, we could have some issues there. Also mentions about the pintle opening, little bump there. All right, so you're going to see that little bump. Change the time base to get a little bit closer if you want to do that as well. So that's a conventional current ramp. That's what we were looking at earlier. We also had peak and hold. It's going to look a little different. So if we go down to the bottom, we have peak and hold. So we have it goes up to a peak, gradual rise in current. We want to see that. And then when it gets to the top, then it drops down to a lower amperage and then holds it. So it peaks and then it holds. All injector ramp patterns should be similar on all vehicles, depending on what kind of injector it is anyways. But each injector should look about the same on a vehicle if we're comparing between multiple injectors as well. So there's a peak, and then it comes down to a much lower amperage for a hold. Then we have pulse width modulated current controlled, and that one looks a little bit different as well. So we have, it's kind of like a peak and hold, but it's a peak, and then it modulates the current after that. So it goes up and down, on off type of a look there. So it looks kind of like a comb on the back end of that. So we have a peak, and then it comes down to a hold, and it just kind of levels it out and it pulses it, right? So current should peak and then drop as current is pulsed. The waveform width may vary depending on how wide how long our on time is on our injector. And then last one is pulse width modulated volume controlled. So on that one, that looks a lot more like that peak and hold, but it just changes with the volume instead. All right, so few different ways to test those, few different injectors in there to test, right? So that's conventional gasoline injectors. We back up a little more, and real quick, we also have pressure transducer tests as well. So we go into pressure transducers, we have a fuel pressure test. All right, so we can go in there and it tells us how to hook it up as well. So we need an adapter to adapt to the tool. There's a couple different ways to do it. I also want to make sure there's a Schrader valve. Easiest way to remove the cap from the valve and install the transducer in its place. The vehicle does not have a Schrader valve, it may be necessary to check pressure fuel filter or inlet to the throttle button. I'll tell you on the examples we gave at the beginning with the animated fuel injector there, that was tapped in before the fuel filter. Because if you do it after the fuel filter is clogged, it's going to give you a bad reading too. So we can check it before the fuel filter if it's easily accessible there on the fuel line. And then also it gives us a couple examples of fuel pressure versus current and fuel pressure versus voltage. All right, so that just gives us a little bit more example there. Throttle body 2 to 4 amps, multi-point port 4 to 6 amps, and then CPI should be 8 to 9 amps depending. And those are just general descriptions, right? Is how we would do that. Now, if I wanted vehicle specific testing, I would have to go in and ID a vehicle. Right now, in guided component tests, there's over 5 million available tests. Goes back to 1981, and they're all very specific to a vehicle. So those are in training and classes is more of a generalized test, but on the vehicle specific test is much more specific. So I have a BMW test board here. We'll go to 2012. It is a 328i with an M52 KP engine. Load in there, and then we see our different systems. You see, it's more than engine. We have charging system, ABS, transmission. There can be up to 12 different systems depending on the vehicle and the information we have. In this case, fuel systems in the engine. And then we go over to fuel system here. You can see all the other different components that we could test. There's a compression test we can do, cam sensor, crank sensor, CAN bus, etc. I want to go to fuel system though. And we'll go to fuel injector. We could also do a fuel pressure test, but we'll go to fuel injector. We go to component information, it tells us how it works. So in this example, it's a conventional fuel injector. So we'll go right to that signature test. If we go to a signature test, it's going to show us the voltage. So we're going to hook up for voltage. We'll hit view meter. It's going to tell us exactly where to hook up. So connect the yellow to the injector control signal, black to ground. Looks like we want to test at the PCM in this case, because it is hard to get to the injectors. And then there's our known good there. There's what we have going on here. I might want to shrink that up a little bit, I think. Let's see. There we go. That's probably pretty good right about there. So there's my fuel injector. There's my voltage. All right, now we talked about testing voltage versus amperage versus pressure. So we could go test these individually, but that'll take a little bit of time. Best course of action is to do it all in the same place, right? So we have our fuel injector here. I want to add some channels. Now, here's a common misconception with the guided component testing is that you can just do one thing at a time and that's it. And it sets it up for you and that's it. And that is not true at all. We can actually add up to 4 channels on a Zeus or a Varus, or up to 2 channels on a Triton or a Modus, right? So I'll make this full screen. I come down to the bottom, I can see my measurements, and then I can also get to my settings. So if I, channel 1 is already on, probe is voltage, all good to go. Scale's 50 volts, looks like we're good there. Channel 2, I want to add amperage. So in that case, we need to go to the probe and change it to amps. So we'll say a 20 amp, low amps 20, that works. Go there. Now, depending on where our amperage is, and this is going to read totally wrong because of how my tester is set up, right? So we're going to see some weird stuff go on there. If we wanted to go down and see maybe a 10 amp or a 5 amp range, we can change that as well. We can see that going on. And then we also have channel 3, we wanted to do pressure, right? So we can go to the probe, click on that, and say, 100 PSI pressure. Depends on what you have for a transducer. That's going to ask you when you hook up a pressure transducer, do you want to calibrate it? So you want to make sure it's connected to the scope, but not the vehicle when you do calibrate it. In this case, we're not hooked up to one, so we're just going to say no, don't want to calibrate it. There we go, and hit back, and then there is all of my information there. Now, if we wanted to go a little higher than 50 PSI, say the vehicle has 60 PSI head pressure like that Ford did, then we'd set it up to 100 PSI on 100 PSI pressure transducer. If we have more than 100 PSI, well, then we need to use a 500 PSI transducer, and so on and so forth. So that's how we would set it up. We could see it right on the screen. We'd back probe wherever they tell us for the voltage, and then the amp probe goes around the feed wire, and then the pressure transducer goes wherever we can tap in to the fuel line, be it at the fuel filter or somewhere else in that fuel line area there. So always best to start with the guided component test, start with those vehicle specific functions on the tool, and then it just makes it easier from there, and then we can just set up and add additional functionality from there. So that is component testing fuel injector. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.